Hi, my name is Dave and welcome to my Solidity Basic series. Here I will guide you through the fundamentals that you need to become a blockchain developer. At the end of this series, you will be able to understand how Solidity works and you will be ready to move on and learn more advanced topics to code smart contracts. So you can find all the videos on Skillshare and I left a link in the description. Please like and subscribe so more people can find those videos and start their blockchain development journey. Hi, and welcome to this first lesson of the Solidity Next Step course. So, as I mentioned in the intro, you really should go through the Solidity Basics course first, so you have a good understanding of what's gonna go on in these lessons. Otherwise, you're really gonna struggle. So, if you didn't already, I will recommend to go back to that. And if you already went through that, welcome back, and thank you for joining me again. So, in this lesson, we're going to talk about inheritance. So what is inheritance? It's a very important capability of Solidity. Inheritance is the capacity to transfer functions and variables to derived contracts, or for now, let's say to other contracts. So what is a derived contract and how do we use inheritance? So this in this picture is just a basic concept of inheritance. We have two contracts, can be more, but for now let's just take two contracts. Contract A, contract B. Here defined as parent and as child. The Solidity documentation calls them base contract and derived contract. So the contract A is the base contract and contract B is the derived contract. So when we connect them like this, it means that contract B inherits all the public and interior variables and functions. Note that the private variables and functions are not inherited, and we're gonna mention that a little bit later on. But so this is how inheritance work in a small function. It can be even very complicated. It can be multiple contracts inheriting from one contract and then last contract inheriting a little bit of all of them. It can be something extremely complicated like this, where there are many contracts involved. And so inheritance is a good way to divide the workload and to isolate parts that we want to have inside or not. So this is one of the contracts, one of the structures that we're going to practice in this lesson is this one here, where we have multiple parents and child relationships. So we'll have one parent contract here, a child contract, another child contract, but then this one is also a parent contract for this contract. And so in today's lesson, we're going to work on something like this. So let's start coding a little bit here. Let's go open Remix, and by now you should be pretty familiar with how this looks. And let's start writing the first contract. So in this one contract here, in this page, we're going to have multiple contracts today. And then we're going to connect them together and to show how inheritance works. So let's start coding the first contract. We'll start with the usual keyword contract, and we'll call this one here first contract. First contract, like this, and we're going to establish a few functions in here, so we can see how we can have other constants inheriting them, and we're also going to introduce some new keywords. So let's start from the first function, and we can just call the number 1, so we know it's the first function that we make here. And we'll make this one public so all the other contracts can access it as well. Pure, because we are not gonna do anything on the blockchain. Here is just to check how inheritance works, and so everything is gonna be internal. And here's we're gonna introduce a new keyword virtual. So virtual means that other smart contracts can inherit this function and use it. So, or rather, other smart contract can inherit this function and modify it. And we'll see in a second how we do that. And then we're gonna return a number. So we're gonna return a uint. And we can simply return a number. Let's return 100. And this is gonna be the first function. Then let's just copy it and we'll make the same function again. We'll just call it number 2 instead. So we have two functions. It has the same attributes, virtual again, because then we can modify it in another smart contract. And let's just change the number to 200, for example, like this. Now, these two functions can be inherited by another contract and modify them. Let's see how we can do that. Or rather, let's first test this contract to make sure that it works fine. So by now you should be familiar with these two lines up here. So we're using the version between 6 and 9. Let's try to compile it, Control S, compiled it correctly. So if we go and deploy it on our JavaScript virtual machine, we'll have first contract here, we'll deploy it. And here we go, we have our two functions, number 1 that has 100 and number 2 that has 200, and that's it. Now let's write a second contract and see how we can inherit those functions. So we'll write another contract, and remember that inside the same page you can have multiple contracts, how many contracts you want. So let's write the second one and we'll call it second contract. Second contract like this. And here we're going to introduce a new keyword again. We introduce the keyword is. So the keyword is, it's how we actually create the connection between the two contracts. So we can write second contract is first contract. And this is the keyword that create the connection. So let's put it here, the connect the contracts. So here this keyword is how we connect the two contracts. So now this second contract is going to have inherited these two functions. So to test this, let's show it like this. Right now we are not writing any new function, any new variable inside this contract. But if we go and deploy it, so let's first compile it, Control S. Then if we go and deploy, let's make sure that we check, because now we have two contracts in here, so we can switch them. Let's make sure we deploy the second contract. We'll deploy it. And if we're looking at, we have the two functions, so we can access them. No problem. 100 and 200. So this is the very basic example that shows how inheritance works. We have one contract here that has nothing in it, but we can use the functions in here. So now let's see how we can take these functions and modify them from the first contract. So we write the function, and to do this, to actually modify it and override it, the function must have the same name of the functions in the first contract. So we'll call this one here number 1 again, and it's going to have the same attributes, public, pure, and then we'll make it virtual again. So we can create a third contract and we can show how that works. So virtual, remember, is to allow us another contract to inherit this function and modify. But we said that we wanted to modify the function in the first contract. So here we have a new keyword, override. So the keyword override is what actually modifies the function. Without this one, we are not going to be allowed to modify what number is returned. And then we're going to return the number again. So we return a uint. And in this time, we will return, the first one was 100, and the second one will return 150. And then if we copy the second function again, and we try to modify this one as well, we'll have number 2, which is okay, because remember, it must be the same name. we're gonna have to add the keyword override, just one bit. And then we can modify the number here to 250, for example. So now let's try to compile it. Control S, and it compiles correctly. And effectively, once we deploy with this second smart contract, we'll be able to call the same function, but instead of being returning 100, it's gonna return 150 because we've modified it. Now, if we remove the override keyword like this, and I try to compile it, it's gonna give an error. See, it's not compiling it. Because it's, hey, you're trying to change something. Are you missing the keyword override? So let's put it back.